Hello students, today we will learn about magnets. You will learn what a magnet is, what magnetism is, what a magnetic field is, and how we can destroy magnetism. A magnet is a piece of metal that can pull certain types of metal toward it. Magnets come in all shapes and sizes. The most popular magnets are bar, horseshoe, and circle magnets. Magnets can be found on refrigerator doors, jewelry, or computers. A magnet only attracts three types of metal. The three metals are iron, cobalt, and nickel. If an object is made of a different type of metal, it cannot attract a magnet. Every magnet has a north and south pole. A magnet's force is strongest at the poles. When touching two magnets' poles together, it's important to remember this rule or law. Unlike poles are attracted to each other, they will stick together. Like poles repel each other. You will feel them push away from one another. To wrap up what we learned so far, a magnet is only attracted to iron, nickel, and cobalt. A magnet is strongest at its poles. The law of magnetic poles states that like poles repel and unlike poles attract one another. Magnetism is an invisible force that pulls certain objects toward a magnet. How does this happen? Every magnet has poles, a north and south pole. The magnetic force is strongest here. Inside magnetic materials are domains. In a magnet, they all face in the same direction. If a substance isn't magnetic, it'll face all different directions. The only materials that have domains lined up in the same direction are iron, nickel, and cobalt. You can create your own magnets using induced magnetism. Induced magnetism is when you turn an object into a magnet by placing it next to an actual magnet. It's important to understand that this can only work with objects that contain some iron, nickel, or cobalt. An example would be taking an iron nail and placing it next to a magnet. I'm sure you've heard that Earth has a north and south pole, just like a magnet. Compasses work by detecting the magnetic field around these poles. Another way to create a magnet is to hit an object that contains iron, nickel, or cobalt and point it north. The domains inside the object will start to line up and become magnetic. The last way to create a magnet is by rubbing an object that contains iron, nickel, or cobalt with a magnet. You need to do this in the same direction many times. The magnet will help the domains line up. Out of the three different ways to create a magnet, this one will create the strongest one. To wrap up what we learned in this section, magnets have domains that line up. This is what makes them magnetic. There are several ways to create a magnet. Each magnet has an invisible magnetic field around it. This invisible field shows the magnetic strength around the magnet. Magnetic fields tell us a few things. They tell us how two magnets will affect one another. They also tell us when poles attract or repel each other. You can see the magnetic field by covering a magnet with white unlined paper and sprinkling iron filings over it. This will show you what the illustrations are showing. In the first, two north poles are repelling one another, and in the second, the north and south poles are attracted to each other. To wrap up what we learned, every magnet has an invisible magnetic field. Magnetic fields can affect one another. We learned all about magnetism, but can it be destroyed? Let's find out. Let's say you accidentally break a magnet in half. What happens? If you break a magnet in half, it will turn into two magnets. They will each have a north and south pole. Breaking a magnet in half will not destroy its magnetism. What if you heat up a magnet? If you hold a magnet over a flame, the heat will destroy the magnetic domains. They won't be lined up anymore. They'll be jumbled and magnetism will be lost. What if you hit a magnet? If you repeatedly hit or drop a magnet, the domains won't be lined up anymore and magnetism will be lost. This is why it's so important to carefully handle magnets in a classroom. To wrap up what we learned, breaking a magnet will not destroy its magnetism. Hitting, dropping, or heat will destroy its magnetism. Magnetism is destroyed when its domains are not lining up.